ADAPT is a decide component which runs as a container on a Docker node. The Docker node runs in a virtual machine in the cloud. Here, we connect to the ACSmI platform acting as cloud broker, and we show the virtual machine where we installed Docker. The virtual machine is the one with the highlighted IP address, ending with the 233 number. Let's connect to a VM terminal with SSH. Issuing the PS command, we can see there are no containers running. Before starting ADAPT, we start a utility container running the Portainer application. Portainer provides a nice user interface which helps in the visualization of the containers running on a Docker node. We connect to the Portainer web interface on port 9000, providing credentials. And we land in the Portainer dashboard page. We can see only one container running on the node, the Portainer container itself. Let's go back to the terminal of the Docker node. We are now going to start the ADAPT container. We name it ADAPT Demo 1. You can see that Docker is pulling the ADAPT image from our private image repository. This process takes some time. Then, we can check again the Portainer dashboard page. By refreshing it, we can see that the ADAPT demo container has started. From the Portainer dashboard, we can also inspect the container, access log files and open a console. Entering the console, we can see a set of files in the main folder of ADAPT. This is the place where ADAPT will create all the files required to apply the deployment actions. Before triggering actions to ADAPT, let's have a look at the ADAPT REST API. The first endpoint we are going to use allows to upload a private key to ADAPT, which is needed to access the virtual machines created on the cloud. So, we make a REST request to ADAPT, submitting a private key for an application named example02. Just before that, we open the output log of the ADAPT container to verify that the HTTP request arrives to ADAPT. Then, we submit the request. We got a 200 response, meaning success. If we double check in the ADAPT log file, we can see that the request arrived properly to ADAPT and returned the success code 200. Now, let's connect to the ADAPT console to see if the key was properly stored. We see that the key has been properly created under the example02 folder, which is the application name. The next step in our demo will be the preparation of the environment in ADAPT for the example02 application. To do that, we will use a dedicated ADAPT endpoint, sending the data needed to get the required information. Let's see the details from our terminal window. We have to tell ADAPT how to access cloud resources and how to get the application descriptor file. This is described in this data structure, where we can find credentials for using cloud resources, credentials for the Git repository, URL of the repository, path of the descriptor file and revision. We send such data structure to ADAPT invoking the endpoint. We can see from the log file that ADAPT is checking out data from a Git repository. Let's see from the GitLab user interface the application descriptor file retrieved by ADAPT, related to application example02. Now, if we check the ADAPT console, we can see that ADAPT created a new example02 folder in the home directory. Inside that directory, we see two more folders, one for the infrastructure to be created, and one for the services to be deployed. In the infrastructure folder, ADAPT created two files, each one defining the steps required to start and configure a new virtual machine in the cloud. In the same way, in the services folder we find a number of files, each one corresponding to a service to be deployed on a virtual machine. If we open one of them, we can find information about the target node, the reference Docker image, the port mapping and many other settings. Once prepared the ADAPT configuration for application example 02, we must trigger a set of operations to ADAPT. ADAPT uses the Terraform tool to manage the infrastructure and the services, which requires 3 steps: initialization, planning and execution. We have an ADAPT endpoint for each of them. Let's trigger the initialization of the infrastructure first, and check what happens on the ADAPT node. The log file states that the platform has been properly initialized. ADAPT saves the initialization states in a console key value store. As we can see, the initialization has created keys for the Terraform states of the infrastructure and services. The content of such keys is almost empty at this time. Now, let's pass to the planning operation. ADAPT will use the Terraform tool to build a plan, describing the operations required to start the 2 virtual machines on the cloud. If we check the log file corresponding to the plan operation, we can see the description of the plans computed by Terraform. Now that we have a plan, we can trigger the real provisioning of the virtual machines by submitting the apply operation. This operation has a long duration, the time required by the cloud providers to start up a virtual machine and to assign a public IP address. After that, ADAPT will perform installation and configuration steps on the virtual machines. We can check on the cloud side that 2 new virtual machines are starting. Then, from the ADAPT log files we can monitor the ongoing creation and configuration of the virtual machines. After a few minutes, the virtual machines are running and have a public IP address. Now, ADAPT can connect to the virtual machines and perform installation and configuration steps. The installations are required to create a Docker environment, while the configurations are mostly related to securing the communication with the Docker daemon. Once finished, we can see the 2 new Docker nodes appearing in the container dashboard. If we access them, we can see that there are no containers running there. Now that we have the infrastructure up and running, let's trigger the initialization, planning and execution for the services deployment phase. Let's start with the initialization step first. This action creates initial configuration files in ADAPT, to be passed to the Terraform tool in the following steps. Now, let's pass to the planning operation. ADAPT will use the Terraform tool to build a plan for the service's deployment, describing the operations required to start the 15 microservices on the 2 virtual machines. Now that we have the execution plan, we can trigger the real deployment of the microservices by submitting the apply operation. This operation takes some time. In fact, for each microservice to be deployed, ADAPT instructs the Docker daemon of the target Docker node to download the corresponding Docker image, and to start a new container. While doing this, it also updates the console key value store with the relevant information about the new service created. We can monitor the service creation on every Docker node from the Portainer interface. If we select the first node, we can see that now we have a set of containers on it. 5 containers are running, while 5 other ones are just created and are going to be started. If we look at the second node, we have the remaining 5 containers, which are started. Now, let's go back to the ADAPT node, and see the output of the console log. The apply operation has finished and all the services are running, each one with their respective node IP address. We copy the address of the front-end service, which is the entry point to our SOX shop application. Before checking the application, let's have a look once more at the console key value store. We can see that ADAPT has updated the store with information related to the deployed services. Now, we have to verify that the application is up and running. We paste the IP address of the front-end service in the browser address bar. Here we are. The SOX shop application has been properly deployed, and its components are distributed over 2 virtual machines belonging to different clouds. We can play around a bit with the application, to verify that everything is working properly. We can browse the catalog, add items to the shopping cart, modify the basket, add another item to the cart and go back to the home page. Let's also verify that the HTTP calls made on the browser are flowing properly to the service containers. From Portainer, we select the front-end container and we open the standard output log. This is the place where the external calls to the application get logged. Let's trigger new requests by interacting with the web application. We can see here that the new requests have been logged by the service. The last set of operations that ADAPT can perform are the undeployment of the services, and the shutdown and removal of the virtual machines. We are going to trigger the destroy operation on the services first. Let's check what happens from the Portainer interface. We can see that the containers have been removed on both nodes. We can also check the console key store, and verify that the data related to the services have been deleted. Finally, we are going to trigger the destroy operation on the infrastructure. If we check the Cloud Broker interface, we see that the 2 virtual machines are stopping. In addition, the 2 Docker nodes that were running there have disappeared from the Portainer interface. Everything has been dismissed.